So the last section in chapter 6, we're going to keep pretty simple, just to give you one example of these equations that we were working with in the last section. Where do they come from? Why do we need to know how to solve them? Well, here's a word problem, and it's very, very similar to, close to what we've already done with a word problem way back in chapter 2. Just a slightly different question. It's a rectangle question. And so if we read it through here, we have want to fence in a rectangular garden with an area of 28 square feet. And then we know the length of the garden is 3 feet less than the width of the garden. What are the dimensions of the garden? This question looks almost identical to a question from chapter 2. The only difference is we talked about perimeter in chapter 2. Now we're being asked about area. So let's use our Ruvessa approach. Ruvessa, remember, is the kind of the checklist to word problems. So we've read it. Remember, U stands for the unknown or unknowns step. So the question of what don't we know? Well, when it says what are the dimensions, we notice the length and the width are both things we don't know. So our unknowns will be length and width. Now, the one thing here, in case you're thinking back somewhat recently, whenever we were working problems as systems of equations, we use this with two variables. We just called one x and one y. But in these problems here in chapter 6, that would not help us. We need to think back to chapter 2. We're just using a single variable here. So we're back to the same chapter 2 approach, which is which of these is the better value of x? Which one can we just call x? Which that takes us back to this sentence right here. The length is 3 less than the width. Okay, I'm trying to ignore all the extra words we don't need. The length is 3 less than the width. That sentence, when you read that, if you remember, what we're supposed to do with that is say, it's telling me something about the length. The length is 3 less than the width. So we're being given some information about the length, but we know nothing at all about the width, which is what makes it the good choice for x. Also makes it the easy choice to then describe length. Because 3 less than the width, 3 less than x, is simply x minus 3. So that's our UV step, right? Unknowns and using a variable to describe them. Now for the equation, that will be where we think about area. We know our area formula for a rectangle is just length times width. And now with that formula, we can create our equation. We know the area is 28 square feet, and we found that the length and the width, length was x minus 3, and the width was x. And we've now written our equation. So again, just to recap really quickly here, our unknowns were length and width. We used that sentence to figure out how to describe them. Then we plug them into our known formula. Notice, this formula is just like that last equation from the previous section. You've got a product on one side, but a number on the other. So we're going to do the move and multiply here as we go to solve this. We need to multiply this out, get x squared minus 3x, but we also want to move that 28 over here. So everything's on one side, set equal to 0. Because notice, as soon as we multiplied this out, we had an x squared. That's what makes this different. This is why we could not have done this problem back in chapter 2. We would have had no clue what to do with this. Now we do. We've got this polynomial equals 0, so we can factor. First step GCF doesn't help us, and it's an easy case, x squared x no x. So multiplying to a negative 28, 1 and 28, 2 and 14, and 4 and 7. Needs to multiply to a negative, so they got to be opposite sign. Add to a negative, so a bigger number needs to be the negative number. So 4, negative 7. So 0 equals our two binomials. We'll put in a plus 4 and a minus 7. Now we can set those factors equal 0. We can make our individual equations. Simple to solve. Oops, add 7. So we get two answers, but now let's talk for a second about these two answers. Two different numbers for this word problem. Well, if we're saying that x can be negative 4 or 7, go back to what x stood for. X represented the width of a rectangular garden. This is where we point out a negative number here does not make sense. It does solve the equation. Officially, you can plug negative 4 in there, but it doesn't make sense, right? I'll just write that. Doesn't make sense in this word problem, okay? The 7, that's fine. We can have a width of a garden of 7, and in fact, if the width of the garden is 7, width is 7. Notice the length, back from our UV step, was x minus 3. So 7 minus 3, so 4. So that works out nicely too, right? So we can get our length, our width and our length. So I'll go ahead and write the full sentence here to describe the answer. We can say the length of the garden is 4, and our dimensions were feet. Remember, square feet, we see square feet because we're talking about an area. But when you actually describe the length and the width, they're always in the one-dimensional units. So in this case, feet. The length of the garden is 4 feet. Oh, Sparky, settle down. That was just a neighbor. Okay. 4 feet. And the width is the 7 feet. And that's it.